Now we're in chapter 9, and chapter 9 has to do with a lot of changing and metrics and things that involve our everyday experience. So here we are, chapter 9, and we're going to start first with linear measurements. Linear measurements. That means something we can put a ruler to of some form. So I have a picture here of a type of measurement used by some civilizations in the past, which was 4 fingers, a cubit, which is mentioned a lot in the Bible, and a span, which is a spread out hand. These types of measurements were used as accepted forms of communication. And what we're going to be talking about is unit conversion. See? A unit fraction. I can speak, really I can. Its value is 1. Okay, and that's because they're identities. All right. Now, in the beginning, I have the English version. And I don't know if English is correct in this sense because the English people have different forms of measurement. But anyway, 12 inches, which the abbreviation is IN, equals 1 foot. 3 feet equal a yard. 36 inches equal a yard. And 5,280 feet equal 1 mile. These are American units of measurement. And what we're talking about is using those conversion factors to change from one unit to another by multiplying by the unit fraction. What we're doing is making sure that, sorry about that, the unit in the denominator measurement of the unit fraction cancels out the numerator beginning unit of measurement. It'll be real simple in a minute. That needs to be introduced, should appear as a numerator of the fraction so that this unit will be retained upon multiplication, because the numerator is the change. The denominator is the cancellation. All right, now what am I talking about? Well, let's start with the 12 inches equal 1 foot. Now, as a unit fraction, I'll do that next here. There I go. As a unit fraction, I can write it as 12 inches equals 1 foot. Now, what this does is it cancels feet and it changes to equivalent value of inches. All right, so now we can see, well, we could have written it as 1 foot equals 12 inches. Again, this is our unit fraction, and this time we're changing from inches to feet. So we can see the utility of using unit fractions. Now you don't have to memorize. the identities. They're always given to you in the problem. So all you have to do is construct what we need. So let's do some examples now. Let's do examples. I'm going to bring down my calculator again for the getting ready. And we have 42 inches, 2 feet. All right, so we want feet in the numerator. Because what we change it to is always the numerator. We want inches in the denominator. All right, here we go. So I'm going to write it as a fraction. 42 inches over 1 times, because we're going to multiply, and we want feet. So 1 foot equals 12 inches. All right, so what happens here, now we're going to do the math, but what happens here is that the inches cancel, and we end up with feet. So let's see what the outcome is. 42 divided by 12 feet. Well, now we use the calculator. Because we know that a fraction is undone division. So, in our calculator, 42 divided by 12. And we'll get a decimal value. So let's do that. 42 divided by 12. And I get 3.5. And I would put the notation of the change, feet. Nothing hard. Now, I wrote a lot because I want you to understand by either reading or listening how I do these conversions. So let's do the next one and see what we can do. Okay, so we're starting with 18 feet and we want inches. So I'm going to put my 18 feet over 1. And I'm going to multiply by my unit fraction. A unit fraction has to have inches on the top. So that's 12 inches equal 1 foot. Now, I have to make sure that the feet cancel, the language feet, and I end up with whatever's in the numerator, inches, as my solution. So, I'm going to end up with 18 times 12 inches. All right, so now I stick it in my calculator. Sure, I enter correctly, because you know, working on a simulator is sometimes it doesn't get it. So this is my answer, and I've converted 18 feet to inches, 216 inches. Again, nothing hard, but again, we have to be careful. 24 inches to yards. So here I want yards. So I'm going to put my 24 inches over 1, and I want yards. Well, I happen to know that 36 inches equal 1 yard. So my unit fraction is going to be, and I want to cancel inches, so 36 inches equals 1 yard. Now let's check to make sure my unit fraction is able to cancel the language in the numerator and denominator, that first one. Inches cancels inches, I have yards. So I am good to go. So now I'm going to say 24 times 1, and 1 times 36, and this is in yards. So we're going to do a decimal value. We know it's undone division, 24 divided by 36, and we get this number. That was kind of crazy, didn't I? And it goes on forever. So we always want to follow the rules. On our program, they want us around to hundreds. And hundreds is 2 decimal places. All right. So I'm going to put 2 decimal places. I evaluate the 6. And 6 is greater than or equal to 5. So we increase place value, the rounding place value. All right. So my answer becomes approximately 0.67 yards. There we go. Again, read to make sure that it's always hundreds. All right, so let's look at this one. I have 12 yards, 2 inches. So I'm going to put my initial value, 12 yards over 1. And I want inches. So inches is above. And I know 36 inches equal 1 yard. Now I double check that the language in the beginning term cancels with the unit fraction, because this is my unit fraction. All right, so I have 1 times 1 in my denominator, so this is simply multiplying. 12 times 36, and we end up in inches, because that's what it asked me to do. All right, so now we're going to take our calculator. 12 times 36. Oops, I mean 12 times 36. My 3 is coming out twice. I must be putting it wrong. And I get 432 inches. Okay, very good. Going along. These are not difficult. Simply keep your little chart. And if you're doing the homework, it shows up on the left-hand side. Excuse me. Now I'm going to go to this one. I have 12 yards, 2 feet. Well, I know that 3 feet is equivalent to 1 yard. So that is our identity. I'm going to make this a fraction. 12 yards, my beginning term, over 1, and I'm going to multiply by my unit fraction. And in my unit fraction, I need feet on top. Now I'm going to verify that the yards cancel, and I end up in my desired equivalent. So I notice that it's only in the numerator, so I'm going to have 12 times 3 feet, and that converts to 36 feet. Solution. Let's do this one. The number's large because we in American measurement, we have this huge number uh, that says 5,280 feet equal 1 mile. All right, and a mile is what we measure as we drive from one location to another. So we have these feet, a very large number. So we're going to write it down. 21,520 feet over the 1. And we're going to multiply by the unit fraction. I need feet in my denominator, so I want miles as my answer. So I'm going to put 5,280 in my denominator, feet. All right, so I'm going to verify that my feet cancel and my equivalent is in that unit fraction, the numerator. So now I'm going to do the math. 21,520 times 1 is, 21,520 over 5,280. And this is in miles. So now I'm going to do undone division for a fraction. And for the calc, and do 21520 divided by 5280. All right, here we go. 21520 divided by 5280. Good. And I get this horrible answer. 4.07575. The dots mean they go on forever. All right, so we want 2 decimal places. When we do that, then I have 4.08 because 5 is greater than or equal to 5, and they're equal, so I increase my place value by 1, and then I put my notation. It is approximately 4 8/8 of a mile. All right, so let's see what we have here. We have 3 9/10 miles, and we want to change it, so I'm going to multiply to feet. So feet is in my numerator, and it's 5,280 feet equal 1 mile. I love these because all we have to do is multiply, because once I cancel that, I get my feet. All right, so this means I'm going to have 3.9 times 5280, and this is in. So for my calculator, it's division. So multiplication, sorry about that. 3.9, and then I'm going to hit the multiply, 5280. And let's see what we do. Get 2592, and this is in feet. That is in feet. Okay. So we're going to talk about lengths and the metric system. The metric system is universal. And it is a base 10 system. Like our money. In other words, we have cents. And we know that 10 cents equals, uh, should have written it out, sorry about that. One dime, and that's 0.10 in the numbers. And then we know that 10 dimes equal $1, and the dollar is 1.00. And then $10, $10. So we can see then 10 $10 bills equal $100 bills with Jim uh, Franklin. And then 10 hundreds make $1,000 bill. So our money is a base 10. And the metric system is a base 10. Used in medicine for accuracy, medicine and products like a liter bottle of Coke, and it is global. In other words, all we use it in science. It's universal. So the metric system is a lot easier to use than ours in measuring what how we measure things. And in the metric, we have what's known as the meter. The meter is that unit of measurement as the center, like the focal point. And then as you go this way, you multiply. If you go this way, you divide by the number of tens you go. And we're moving the decimal. So um, it's a very easy system to use. Well, naturally, we have an acronym so that it makes it easy to remember. That's all that is. All right, so let me pull that up. Okay, so the acronym is King Henry died Monday drinking chocolate milk, using the first elements to what it is. And the meter is in the center. Now, in science, we go even smaller than millimeter. And so what we have is a kilometer, and we go larger than a kilometer. Hectometer, decameter, meter, decimeter, centimeter, and millimeter. So these notations are referencing from this is as small as we can go, and this is as large as we can go in this course. In science, you would go smaller and larger. So let's begin our journey of converting and using. We need to know which direction. Because if we go to the left and decimal moves to the left, that many changes. And if the left means that to the right, decimal moves to the right. usually inserting more zeros, that many movements. All right. All right. Now this is not a difficult homework at all. There is a lot of problems, but that's just to give you strength in what we've learned. So remember what we said. Died Monday. This is our meter. Drinking chocolate milk. All right. So this guy right here is our key. So we're starting at 6 meters. So we're starting here and we want centimeters. So this means I would move 1, 2 places to the right. So I take my 6. Every whole number ends in a decimal. And that means I move the decimal to the right 1, 2 movements. So this gives me 600 centimeters. Centimeters means parts of 100. Smaller containment of that value. So let's see this one. Let's see what we have here. See if we can do. So we're going to do our King Henry died Monday drinking chocolate milk. So here we start at hectos, right here. That's where we start. And we're changing to meters. So we're going to the right, 1 and 2, 2 to the right. So I'm going to put the 17 and 9/10, and I'm moving to the right, 1, 2. There you have it. Here we have another one. And on this one, we have centimeters meters to hectometers. Oh my goodness. So we're going to have our King Henry died Monday drinking chocolate milk. Right, so here we go. All right, so I'm starting here and I'm moving to the left. So how many movements? 1, 2, 3, 4. All right, so I'm going to put my number, and I'm moving 1, 2, 3, 4. So the decimal is 4 movements to the left. So I'm going to rewrite it. This is now in hectometers. All right. So here is another one. And it says millimeters to meters. All right. So we're talking about King Henry died Monday drinking chocolate milk. And we're saying millimeter to meters. So we're moving here. 1, 2, 3. All right. So I'm going to put my value. Here's my decimal. I'm moving the decimal 1, 2, 3. 1, 2, 3. And now, of course, I've changed it to a larger measurement, meters from centimeters. Okay. I'm going to stop right there, and we'll start up with converting English into metric and metric into English.